ANSYS Simulation, Lecture 10, Parametric Analysis. In order to transfer these two-dimension parameters onto ANSYS, we need to rename these two dimensions. We will name this horizontal dimension as width of the beam, W, and ds is the code to transfer parameters onto ANSYS. So if you rename a dimension as ds, ANSYS will recognize that this is going to be a parameter. So we do the same thing for the vertical dimension as h, the height of the beam, and ds is also the keyword for parameters on ANSYS. So we'll tell ANSYS that these two dimensions are parameters. So now for the preparation step, we must load the software and then enter ANSYS Workbench. And we will also define another parameter, material parameter, of Young's modulus. And there will be 3 parameters in this problem. First of all, we drag the static structure analysis onto the geometry and edit materials so as to define parameter. So we define Young's modulus as parameter by checking this checkbox parameter P here. So Young's modulus as parameter, checking here. And we'll go back to project, and you can see that P1 will be Young's modulus. So we have declared P1 as a parameter. And we'll enter ANSYS mechanical. Remember that we transfer 2 dimensions from SolidWorks to ANSYS. So once we enter ANSYS mechanical, we will look for the 2 parameters here in the geometry, and we click on the checkbox to make these 2 dimensions parameters. So these dimensions are parameters. So we have 3 parameters. One is Young's modulus, and the other 2 are width and height of the beam. So now we'll connect the material property with the geometry and then mesh. And boundary condition at the right surface. And loading concentrated force on the left surface, area of the load, direction of the load, toggle down, apply, magnitude of the load. So we have finished with the preparation steps 1 through 4, the preprocessors actually. And so we can go ahead and solve for the procedure, and we'll define total deformation and equivalent or von Mises stress and solve. And for the result, we need to check the maximum displacement as parameter and maximum stress as a parameter. So we check 2 parameters of the solution of the result, and then we go back to the schematic interface and enter parameter set, and we'll edit the combination of scenarios. For example, we copy the Young's modulus 4 times, and we'll edit the parameters, for example 60-60, 60-50, and 50-60, and 50-50. And also we copy this Young's modulus and change it to 3 times 10 to the 5th MPa, and 3 more times. So we have 4 scenarios where the Young's modulus is higher, and 4 scenarios where Young's modulus is lower. So we can edit these dimensional parameters as before: 60-60, 60-50, 50-60, and 50-50. So we have 8 scenarios here. Because we have 2 levels of P1 Young's modulus and 2 levels of P2 width of 60 and 50, and 2 levels of P3 height of the beam 60 and 50. So we have 2 times 2 times 2. There will be 8 scenarios for the combination of the 3 parameters. So we will solve for the cases all the 8 scenarios. And the procedure will run all the scenarios for me, but it will take quite a lot of time to do that. And in this problem, in this lecture, we talk about a parametric analysis, so that you can calculate many scenarios or many cases at the same time. It is the most convenient solving these problems in an element library or a bunch of elements or parts with similar aspects. So actually this is a solution of part library or parametric analysis.